In the same study, middle-aged mice and older mice were also given MOTS-c, and their aerobic and anaerobic exercise performance also improved. But the older mice also saw an improvement in their grip strength. However, the younger mice did not. There are less other studies on strength improvement, and MOTS-c definitely seems to more positively impact those slow twitch muscle fibers, or those that are more involved in endurance performance, compared to the fast twitch fibers, or those that are more involved in maximal strength and power. And this makes sense mechanistically because these slow fibers are much more reliant on mitochondrial function, which is supported by the AMPK activation that MOTS-c provides. And interestingly, in a study looking at a human genetic variant of MOTS-c that has less biologic activity, researchers found that those with this variant, and thus functionally less MOTS-c, had more fast twitch muscle fibers and higher measures of leg strength. And those with this lower MOTS-c activity were slightly more likely to be strength athletes compared to endurance athletes. And then further adding to the story, when mice were injected with a substance made to inhibit MOTS-c, their fast twitch fibers actually increased. So it makes sense that exogenous MOTS-c is more beneficial for markers of muscular endurance when tested in mice, but not so much for maximal strength markers.